So real quick, let's just kind of take a look here at SOHCAHTOA and its reciprocals. So there are three new trig functions that we want to be able to look at, what we call cosecant, secant, and tangent. And so for your reciprocal properties, you want to try to remember kind of which ones go together. And an easy way to remember that is that the first letter is not going to match. So for cosecant, cosecant is the reciprocal of sine. And the way that in math terms we write reciprocal is to write 1 divided by that value. Right? Now you're really not going to be dividing, it's really just the notation. Really what we're going to do is we're going to figure out what the value is of sine and then flip that fraction to get cosecant. For secant, that is the reciprocal of cosine. So you can see that the first letters don't ever match. And again for the cotangent function, right? The cotangent function, the reciprocal for cotangent is 1 over tangent. So our different trig functions, sine, cosine, and tangent, are the reciprocals of other 3 trig functions. Now sometimes you're going to also need to be able to work your way backwards. And so if cosecant is the reciprocal of sine, then sine is the reciprocal of cosecant. So you can see that they work together. They're reciprocals of each other. Same thing that cosecant is the reciprocal of secant, and tangent is the reciprocal of cotangent. Right? Now what we want to be able to do is we want to be able to use reciprocal properties to evaluate the different trig functions. So let's look at this triangle right here. Right? And so with this triangle, what we want to be able to do is we want to be able to look at different different theta and different beta trig functions. So again, I'm going to call this down here theta and beta, and my different legs are going to be 5, 12, and 13. And so if I'm asked to find the sine, cosine, tangent, or if I'm asked maybe to find all 6 trig functions, here's what we would get if we use SOHCAHTOA on the various trig functions. So the sine of the angle labeled theta is 12 over 13, cosine is 5 over 13, and tangent is 12 over 5. Now, to find the cosecant, secant, and tangent, we're first going to think about, well, which one is the reciprocal of which. So in this case, cosecant being the reciprocal of sine, secant being the reciprocal of cosine, and cotangent being the reciprocal of tangent, all I'm really going to do is just flip those fractions that I have next to their reciprocal identity. So for cosecant, I'm just going to take my sine fraction and flip it. That's how you really write reciprocals. Again, so this up here is just the notation, but that's really all we need to do. We just need to flip the fraction. So you can see that if I write my values for the 6 trig functions in this specific order, it's pretty easy to find the first 3 and get the second 3 by just flipping the fractions. Now, what if I am asked about these 3? All right. So again, if I'm referring to the other angle, I can ask any of the other 6 trig identities for the other angle. So in this case, the tangent of beta, the opposite side is now the leg 5, and the adjacent is now the side 12. So my fraction for the tangent of beta, you can see, is not the same as the tangent of theta. Right? Cosine of beta is now 12 over 13. But what if I'm asked to find the cosecant of beta? So the cosecant of beta, well, I want to remember that cosecant and sine go together. So the first thing I want to do is say, well, what would be the sine of beta? So the sine of beta would be 5 over 13. So to write the reciprocal, I would need to flip that and get 13 over 5. So if you're asked to find one of the trig functions, sine, cosine, or tangent, it's really easy to use SOHCAHTOA.
But if you're asked to find cosecant, secant, or cotangent, you're going to need to know the reciprocal function that goes with that, so that way you can flip the fraction. Right? So let's look at one more. What if I have this fraction right here? Oops, sorry about that. Let's cover up our answers. Sorry. All right. So say I'm given a triangle, right? A triangle where I might have to maybe use the Pythagorean theorem. Actually, in this case, I did. So I used the Pythagorean theorem to find out that the length of this leg was 24, because I wasn't given that originally. All right, so if you're only given information about part of a triangle, like one leg and the hypotenuse, you need to remember that to do anything with this triangle, you're going to need to use the Pythagorean theorem in terms of SOHCAHTOAs to find that side. So if I set up my Pythagorean theorem, I'm going to get that this leg is also 24. And so what if I want to find the different degree measurements? You know, based off of these ratios, what is the actual degree measurement of C and A? All right, so for those, I'm going to use my trig functions. All right. All right, I'm going to set up a couple of different trig functions here. And again, it doesn't really matter which of the trig function I use, because I have all three sides, and so my ratio is going to be whatever I decide to use in my calculator. All right. So if I just say, let's just for any reason at all, I want to find C, and I'm going to use the sine function. To do that, I need 24 over 25 as my ratio. And for tangent of A, right, again, for A, I could use sine, cosine, tangent. I can use any one of them I want. I'm just going to choose that specifically. I would need the ratio of 7 over 24. Right? And when I put those into my calculator, right, I end up with the degree measurements, and I rounded these to the nearest hundredth. But you're going to need to play around with your calculator and see how your calculator works when you're dealing with trying to find these degree measurements. Again, if you're using one of the non-school calculators, all right, it's a lot easier to plug in these values right into your calculator to get the degree measurements. You're just going to have to do a little bit more work if you're using a school calculator. But you can see that based off of the inverse trig functions, I end up with two values for the other two angles, and these add up to be 90 degrees, and so that kind of coincides with the inside measurements being equal to 180 if I add up C, A, and then the 90 for B.